Let's start with the concept of work. What exactly is work? Work is defined as force multiplied by distance. This distance is in the direction of force. So therefore, the force and distance should be in the same direction. Unit of force is Newton. Unit of distance is meter. Therefore, unit of work is Newton meter. But instead of Newton meter, we write the unit joule. So that is the unit of work done. Now let's calculate work in different scenarios. In this particular question, the question says a box is pulled 7 meters across a horizontal floor by a horizontal force of magnitude 15 Newton. Calculate the work done by the force. So now in this question, let's draw a horizontal floor, and there is a box over here, and this box moves 7 meters to this particular point, and the force that moves this box is a horizontal force of magnitude 15 Newton. So the work done by the force is equals to force, which is 15 Newton, into distance 7 meters. So this comes out to be 105 joules. That is the basic working for work done by a force. Now, whichever force is doing the work, it's that force multiplying by the distance. This question says a bricklayer raises a load of bricks of total mass 30 kg at a constant speed by attaching a cable to the bricks. Assuming that the cable is vertical, calculate the work done when the bricks are raised a distance of 7 meters. So let's say this is the cable, and below it is this particular load of bricks. The load of bricks have a total mass of 30 kg, therefore the weight is 30 g Newton. The tension therefore has to be equal because it is moving with constant speed. Remember, if a particle is at rest or if a particle is moving with constant speed, the resultant force is 0, so tension equals to the weight. Now let's calculate the work done by this tension. That is the magnitude of tension multiplied by this distance. So therefore, the work done equals to 30 g. The value of g is 10 multiplying with 7. So 7 into 3 is 21, and the 2 zeros gets attached. So this is the value of work done, which is 2100 joules. So the second question is done. We are doing these small questions to clarify our concept about work. Let's read the third question. A sledge is pulled 15 meters across a smooth sheet of ice by a force of magnitude 27 Newton. The force is inclined at 25 degrees to the horizontal. By modeling the sledge as a particle, calculate the work done by this force. So first of all, let's draw the floor, which is an ice floor. And then on top of that, let's draw the sledge. Let's treat it as a particle. And then this is the horizontal, and a force of magnitude 27 Newton is acting this way, and this angle is 25 degrees. So the weight component horizontally is 27 cosine of 25 degrees. Now this weight component, the horizontal component of this force, will make the sledge slide 15 meters across the surface. So therefore, the work done by the force is 27 cosine 25 degrees multiplying with 15 meters, and this answer comes out to be 367.0 joules. The answer is given correct to 1 decimal place. Now let's look at a different question, something like this. The question says a packing case is pulled across a horizontal floor by a horizontal rope. The case moves at a constant speed. That means the resultant force is 0. And there is a constant resistance to motion of magnitude R Newton. When the case has moved a distance of 12 meters, the work done is 96 joules. Calculate the magnitude of the resistances. So very first thing is drawing a horizontal floor. Second thing is that let's draw this case. Now there is a pulling force. Let's call it P. There is a resistive force. Let's call it R. Since the case is sliding with a constant velocity, therefore P equals to R. Now let's write down the formula. Work done against resistances. So now this is resistive force multiplying with distance. So the resistive force is R and it's multiplying with distance T. Work done is 96 joules. R is what we are looking for. Distance is 12 meters. So therefore R is 96 over 12, which simplifies to 8. So 8 Newton is the resistive force. And if they would have asked for the force that was applied, that's also 8 Newton because the case is traveling at constant speed. Let's move on to the next question. Now it says a package of mass 2 kg is pulled at a constant speed up a rough plane which is inclined at 30 degrees to the horizontal. Coefficient of friction between the package and the surface is 0.35. The package is pulled 12 meters up a line of greatest slope of the plane. Calculate the work done against gravity. Calculate the work done against friction. Now, first of all, let's draw an inclined plane like this. Let's mark this angle as 30 degrees. We know that sine of 30 degrees is half. We know that cosine of 30 degrees is root 3 over 2. Half in decimals can be written as 0.5. Root 3 over 2 simplifies to 0.8660. Correct to 4 significant figures. Now, let me draw the particle over here. I'm drawing the two components of weight. One along the plane is mg sine theta. The other one perpendicular to the plane is mg cosine theta. Let's also label R, which is the normal reaction force, and let's read the question. A package of mass 2 kg is pulled at a constant speed up a rough plane. So therefore, F max is also acting down, that is this way. Now we know that work done against gravity should be gravitational force into distance. So what is the gravitational force? There are two options. The first option is either I use the formula mgh because mg is the weight and h is the height. Now, if I use trigonometry, this is h, the distance that it moves up is 12 meters and this angle is 30 degrees. So therefore, sine of 30 degrees is h over 12. Since the value of sine 30 is half, so half is equals to h over 12. Therefore, h comes out to be 6 meters. So I can use m as 2, g as 10, h as 6. So this comes out to be 120 joules. That's one approach. What is the other approach? The other approach is work done against gravity is defined as mg sine theta into distance along the plane. Now this is mg sine theta, the weight component along the plane, and it's moving a distance of 12 meters along the plane. So therefore I'll write m, which is 2, g, which is 10, sine of 30 degrees, which is half, and distance along the plane is 12. We know that sine of 30 is half. This is 2. It cancels off. 10 multiplying with 12, that comes out to be 120 joules. That is how the work done against gravity is calculated. When you use the vertical height, you should use the weight as it is. When you use the distance along the plane, then the weight component along the plane is used. Now let's focus our attention to work done against friction. What is R equals to? Mg cosine theta. What is F max? Mu R. So let's do this calculation. We know that R is mg cosine of theta and F max is mu multiplying with R. So that is mu mg cosine of theta. Do we know the value of mu? Yes, we know the value of mu, which is 0.35. So let's plug it in things over here. So we have mu, which is 0.35 into 2 into 10 into cosine of 30 degrees. So that is 0.35 into 20 into 0.8660. Leave it as it is. Now we know that work done against friction should be frictional force into distance. That is F max multiplying with distance. What's the value of F max? That is 0.35 into 20 into 0.8660. And yes, it's also acting along the inclined plane. That value is 12. So now using a calculator, multiplying out all of these gives me the answer as 72.7 joules. This answer is given correct to 3 significant figures. So that's the working that we did to find work done against gravity, and the similar working was done for work done against friction. Now let's look at the last question. The question says there is an inclined plane, sine of theta is given, cosine of theta is given. A mass of 50 kg is there on the inclined plane. It's moved up the plane at a constant speed. The distance along the plane that it moves is 5 meters. The resistances that it overcomes is 50 Newton. And let me write it down. It's moving at constant speed. That means the forward force and the backward forces are equal. And this time I'm interested in finding the work done against resistances. So now it's a sum of all the resistances. So the working is pretty simple. Work done against resistances is resistive force of 50 Newton into distance 5, which comes out to be 250 joules. Similarly, if I'm interested in finding work done against gravity, so therefore I have to use the formula work done against gravity. I'll just use one of them, that is mg sine theta, the weight component of the particle down the plane into the distance d that it moves. So m is 50, g is 10, value of sine theta is 3/5, and the distance that it moves along the plane is 5 meters. So let's simplify things. These two numbers cancel out. 50 into 10, that's 500 into 3. This comes out to be 1500 joules. So what have we learned in this video? Whenever we are asked to calculate work done, we just identify which force or forces are they talking about. For example, if they are asking about work done against resistances, we take the resistance force or the sum of resistive forces, which is 50 Newton, and multiply by the distance along the plane. Similarly, work done against gravity is gravitational force into distance. And if we continue looking up, for example, in this case, it's also about work done against resistances. Similarly, in this particular question, we took the horizontal component of force, multiply by the distance, and we get the work done by the force. That's what this video is all about.